this video, we're going to look at the problem. On a construction site, the precarious situation as diagrammed below has occurred. What is the tension in the rope? All right, so the precarious situation we have here is we have a beam with a weight of 200 newtons that is being held up on one end, the very tippy top, on top of some sort of structure here. And at the other end, it's being held up by a rope. So we have this beam being balanced between some sort of structure where the beam is sitting at one end and then a rope attached and holding it up at the other end. All right, so our goal is to find the tension in the rope. All right, so let's go through our problem solving steps. For step one, we want to sum torques or forces on the beam because we want to find the tension acting on the beam. For step two, let's label our diagram. So we have a tension pulling up at this end. So on the right end, we have a weight pulling down at the center, so the weight of the beam. And then the structure is going to exert a force normal up on the end of the beam. All right, so we have our diagram labeled. For step three, we need to pick where we're going to set R equals 0 at. So we have three forces, and our goal is to find the tension over here. We have the weight of the beam, but we don't know the force normal, and we're not trying to find it. So that means I'm going to put my 0 point at the location of Fn. So right here. All right, and then we can write down our conditions for mechanical equilibrium. So we're going to have three torques. One due to the force normal, one due to the weight of the beam, and one due to the tension. All right, and we only have a y direction here. There's no x direction. So we would have force normal minus weight of the beam plus the force due to tension equals 0. Now we can't use Newton's second law initially because we don't have the force normal and we're trying to find the tension. So there's two unknowns here. So we're going to go up here into the torque and take advantage of the fact that we set R equals 0 where the force normal is. So I'm going to do force normal times R normal plus force B times RB plus force of tension times R of tension equals 0. All right, so because we've set R equals 0 at the one end, the weight is going to cause clockwise rotation, and the tension is going to cause counterclockwise rotation. This means that I need to make this torque here actually negative. So I'm going to do Fn times 0 meters minus 200 newtons. Remember, the weight is always applied at the center, which means that, let's see, this beam seems to be 3 meters. So it means half of that would be 1.5 meters. And our tension is here, that's our unknown, times the length of the board, so that's 3 meters, where that tension is located. All right, so I'm going to do 200 times 1.5, so that's going to give me a negative 300 Newton meters, plus the force due to tension times 3 meters equals 0. And then I'm going to add that 300 Newton meters to the other side, so we get force of tension times 3 meters equals 300 Newton meters. So I can divide both sides by 3. That's going to be a force due to tension of 100 newtons.